this is best academic. And in today's class, I will be taking you guys through exponential differentiation and logarithm differentiation. So now let's actually differentiate exponential with our eyes. Okay, we have got in terms of exponential differentiation. Whenever a function is actually written in this format, that is y equal to e exponential u. Now that this is exponential differentiation, so whenever you see any expression, there's any function written in this format, how do we differentiate this? But before then, I have to tell you guys how we differentiate with respect to. So if I see y equal to exponential e, I should be able to know the letters here involved. I have y, I have u. But just know that whenever you want to differentiate, you differentiate between the dependent variable and what? Independent variable. That is the ratio of dependent variable and independent variable. So now let's know the letter that is independent and independent. If I have this to be y equal to f of s like this. Now the letter that is the subject acts as what? Dependent. While the letter that is what? That is not the subject acts as what? Independent. That means y is dependent, s is what? Independent. So differentiate this to be the y over what? The s. But if I have this to be, maybe I have y equal to 2t squared like this. So to differentiate this guy here is going to be the dependent is y, independent is what? T. And I told you guys that the derivative is always the ratio of the dependent variable to what? Independent variable. Please take it. Dependent over what? Independent. So dependent here is y, independent is what? T. So it's going to be dy over what? T. Please take it. So this is how we express our derivative. So to express my derivative here at this point here, it's going to be dy over what? The u, because the dependence here is y. That is solid relative here is y. While the letter that is not the solid is what? U. So how do we now use our eyes to differentiate exponential? They just take it. To differentiate exponential, if I have a format here, a function here, y equal to exponential u, is going to be dy over du equal to u exponential u. Let me tell you what to do. You differentiate the upper one here, you take it down, and you repeat the equation. You differentiate what is at the top here, at the top of exponential. You take it down, you repeat the equation. So now let's apply some equations here. Example 1, please. Okay, we are giving equations like this. Let's try to solve these examples. A, we are giving 5 y prime, and y prime is same as what? The y gets this statement. Given that y is equal to exponential s squared, B, we are giving find ys if y is equal to 2s squared because 5s. And C, we are giving given that y equal to exponential tan u, find dy du. So now let's try to solve this one after the other using this format here. Remember, I told you guys that to differentiate any exponential here, this statement, it means that you have to differentiate what's at the top here, bring it down, and repeat the equation, this statement. So let's differentiate this guy here, this statement. Let's differentiate this guy here. Now I have this to be y to be equal to e s squared. Now to find the derivative or to express the derivative here, I have to pick up the letters here. Independent is this, independent is y. So this is going to be dy over dx. Please look up here. Differentiate this guy here. Now how do we differentiate? There's what we call derivative by monomial function and polynomial function. So I have this to be y equal to ax raised to n. This is what we call monomial. That means it has one number, one letter, and a power. So our dy over dx will be equal to, take this power here down to the base and subtract 1 from it is going to be n a s raised to what? N minus 1. this is how we differentiate polynomial functions. There's any one that have one number, letter, and a power. Please take it. So if I have this to be y equal to for polynomial that's more than one digit, this is going to be equal to maybe ax, this of n, plus bs, this of n, and up. So to differentiate this will be our dy over the x, and we differentiate this one after the other. Differentiate this is going to be n of a of s, this one minus 1, plus take this part down to the base to be n of b of s, this one was minus 1, please take note of this. So this is monomial, this polynomial. Differentiate this, take the part down to the base, subtract 1 from it. This one here, differentiate one after the other. If there is plus there, you put plus, there is minus, you put minus, please take note. So now let's differentiate this guy here. Differentiate this guy here, please take note. Take this part down to the base is 2, subtract 1 from it to the what? 2s, 2s. So take the answer down to the this will be 2s. Repeat the equation, what is the equation? Exponential s squared. This is the answer. So please take note of this. So now let's solve the next one here. Let's solve B. Let's solve B. Now to solve B here, you can know that this is what? Polynomial, right? So I'll differentiate the top. So differentiate the top here. I will take the answer down and you read this equation. So now let's go. Okay, let's start with equation B here. Let's say find dy du. If y equals to, can divide du please. Find dy dx. Sorry for that. Okay, y because the letter here is y. That is dependent is y. The independent is what s. So it's going to be the y over what the x. So I have this to be that is y is equal to exponential 2s squared plus 5s. And at this point here we are asked to find dy dx. Please take it. So I told you guys this is short way here. Just open your eyes here. Differentiate this top here. Differentiate the top here. Please take note. Take the result and to the base. This will be our dy over dx. We equal to differentiate what's at the top here. That means if I have 2s squared plus 5 here, then differentiate what is at the top. Take the power down to the base, that is 4x, base of 1, please take 1 plus, differentiate this invisible one here, what is the answer? 5x, sorry 5 only. That is, this will be 2 minus 1, this will be x, base of 1 minus 1, please take it. Simplify this, I'm going to have 4x plus, now 1 minus 1 will give us over here, x is equal to what is the answer? 1, right? Now 1 times 5 gives us 5. This is my result here. Please take it. Now repeat the answer here. Repeat the equation, sorry. This is going to be exponential 2s squared plus what? 5s. This is how we differentiate exponential function. Okay, lastly, C. Let's differentiate the last one here. That is y. They say given that y is equal to exponential times u. Find dy du. Why is it dy du? Because dependent is what? Y. Independent is what? U. Please take it. So the derivative here is going to be y or what? Du. Please take it. So now let's differentiate this. Okay, now let's differentiate this right here. I have this to be y to equal to exponential times u, and we are asked to find dy du. Please take it. So to do this here, I have to know how to differentiate time as trigonometry. Now there's special differentiation here. Let's know about trig. So if I have this to be my function, I have this to be my derivative of the function. Please take it. If I have sin x, the derivative of this guy here is going to be cos x. If I have cos x, the derivative of this guy is going to be minus. This is the technique. Whenever anything is appearing to be c at the beginning, whenever 3 appears to be c at the beginning, the answer is always negative of something. This is minus sin x. If I have tan, please take note, tan x. The answer will be sec square x. Please take note. If I have maybe sec x. Now whenever c occurs at the end, if c occurs at the beginning, the result is always minus. If C occurs at the end, it means that I should repeat this guy here and combine it with anything that you differentiate, you are going to get sec. So this is going to repeat this guy here with sec x. What is that? Whenever you differentiate that stuff, you are going to get sec. It's going to be tan x. So this table of this. Now this is not the simplest way to know this. There's no other method to know this. Now the next tool here is cos. And I talk cos x. And I told you guys, whenever you want to differentiate anything that's any trait that appears to be C at the beginning, is going to be minus cos sec square x. If I have cos sec x, there is C here. The C is minus. There is C at the end. It means repeat this line and combine it with anything you differentiate. You are going to get cos sec. This is going to be cos sec x. And what? Cos x. So let's take of this. So now let's differentiate this guy here. This will be dy over du equal to plus. Differentiate this guy. Let's go. If I have tan, what is derivative? This is going to differentiate this guy here. Take it down. This is going to be sec square. Now my letter here is not s, it's u. That means this will be sec u. Repeat the equation. What is the answer? Exponential tan u. I told you guys, to differentiate exponential, you differentiate what is at the top, you take it down, and you repeat the equation. That is how we differentiate this here. This thing. Now if you put this for me, if y equal to exponential sec x, find dy over the x. You can do this for me. Okay, thank you so much.